All right, this is number 4 in the series worksheet. By now, you should be doing this on your own, okay? So if you have not done this problem and you're watching this video, that is no, 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 no. You need to do it yourself first, then watch the video to check it, or if you need help, okay? But you need to try it yourself first. Do not just copy all the videos. All right, no good. All right, the battery creates a 20-volt difference. Resistor 1 is 3 ohms and draws a current of 3 amps. Resistor 2 has a 3 voltage drop across it. Okay, so now we've got a little bit of different stuff going on here, all right? So same thing, I'm going to have my battery. I have an ammeter. I have a resistor. Another voltage circle. Okay, and look, now there's a light bulb too down here. Okay, so here's another ammeter, and then I have another light bulb. Okay, so there's actually 3 resistors in this circuit. 2, 3. Okay, and remember, I'm just going to draw a light bulb like a resistor because pretty much everything in a circuit that's an energy user is a resistor. Okay, so whatever. Okay, let's see what we've got now. The battery creates a 20 volt difference. So that's my total. Resistor 1 is 3 ohms and draws a current of 3 amps. Okay. Resistor 2 has a 3 voltage drop across it. And that's all I got. Okay. All right. So let's go ahead and label these. This is R1, R2, and R3. Okay. First thing always to do is, if you know it, track, you always know 0, right? So track that to the battery. And in this case, I also know that it's a 20 voltage battery, so I can carry this 20 all the way across until I get to a resistor. Okay? All right, now I don't really have anything else. So now I have a couple of options, okay? So one is that I can see if anything has 2 out of the 3, right? Anytime it has 2 out of the 3, I can calculate the other one, all right? So in this case, I see in resistor 1, I know it's 3 amps and 3 ohms, right? So if V equals I times R, 3 times 3, I know this is going to be a 9 volt drop here. Okay. All right, and that doesn't help too much because I can't really do anything else. All right, so now I need to think about, what do I know about a series circuit? Okay, I know a couple things. I know that the voltages will add to the total. I know the current is the same, and I know the resistances will add to the total. Okay, that's just something you need to know about a series circuit. All right, so I immediately can see here, well, if this is 3 amps, all of these are going to have to be 3 amps because it's a series circuit. So I'm going to go ahead and fill in all these ammeters as 3 amps. Okay, and that's opened up a little bit more information for me. Now I have 2 out of the 3 in more places. Okay, but what I want to point out here, right, is I can figure out what this third voltage drop is based on what's available. Okay, so if I had 20 volts to start with, resistor 1 got 9, resistor 2 got 3, then the third resistor is going to have to get the rest, right? Because it has to go to 0. So let's go ahead and look at it in the circuit. So if I drop by 9 volts here, okay, what's going to go in this circle then? 11, right? That's going to be something that you're going to get confused about, right? I don't put 9 there. The drop is 9. Okay, so 20 minus 9 gets me to 11. Okay, then we know this one's going to have a 3 volt drop. Okay, so 11 minus 3 is going to get me to 8. Okay, so then here I can see this has to drop from 8 to 0. All right, so that means this is going to have to be an 8 volt drop. Okay, right? Because 9 plus 3 is 12, plus 8 more would make 20. Okay, all right, then I can just go ahead and calculate the rest of these and make this a little bit easier on myself, okay? So 3 equals 3 times R, okay? So remember, if you need to work it out all the way, go ahead and work it out. Okay, so R is going to equal V over I, which is 3 volts in 3 amps. So this is going to be 1 ohm, okay? Similarly, 8 over 3, I know it's going to be a decimal, don't freak out, it's going to be okay. It's going to round it to the 10th, 2.7 ohms, okay? And then if I add all these together, right, because I know in a series circuit, the resistors add to the total. All right, 2.7 plus 1 plus 3 is going to be 6.7 ohms. Okay, then you might want to check, right, 3 times 6.7 should be 20, okay, which it is. It's rounded a little bit, okay, so don't freak out. It's going to be like 20 point something, right? Okay, so 3 times 6.7 is going to be 20, so now I know it's right. Everything checks out. All right, okay, so last thing I want to do is my diagram. So I'm going to have, A, B around the battery, C, D around this resistor, E, F around this resistor, G, H around this resistor. Okay, so A, B, C, D, E, F, G, H, and then back to A. All right, and I have to get to 20, so I think I'm just going to go by 5s. All right, so from A to B, I'm going to have an increase of 20. Okay, then I'm going to have the flat part from B to C as I cross the wire to the resistor. Okay, my first drop is going to be 9, which puts me at 11. Okay, so this next one is going to have to be at 11. Minus 9. Okay, this should be at 11. Okay, and then another flat part as I cross the wire. Okay, my next voltage circle is going to be at 8, right, because I've lost 3. So minus 3 volts puts it at 8. And then another wire, F to G. Okay, and then my last drop here around the third resistor is going to be an 8-volt drop. That should get me back to 0 always. Okay, and then back to the battery. All right, so there is the solution for number 4.